Hello everyone. In this video, we will review basic algebra and solve for simple equations. Before we get started, let's review the language of algebra. The terminologies that we are going to use throughout the entire unit and throughout the course is the variables, the coefficients, the terms, like terms and unlike terms. These are the common terminologies that we are going to use for the unit that involving algebra and anything that involving algebra. Alright, letters are called variables. Okay, so if I have letters A, B, C, D, E, F, X, Y are called the variables in the language of algebra. For this unit and for this topic, we concentrate on A, B, C, X, and Y. But you, in fact, can use any letters that you would like to present them as a variable for algebra. So why do they call it variables? Because when you get into advanced algebra, they represent it as a changing. You can substitute any values in here. It's a changing variable. Variable, that means you can change it. You can substitute any values in here. Alright. Coefficients are numbers. Okay. Are numbers. Integer, fractions, real numbers. The example that I will be using for this topics for this class are just integer and fractions for the coefficients. Okay. So in other words, like all the numbers that you see in the language of algebra, it's called coefficients, and this number attached to a variables. Okay, so if you have variable and coefficient attached to each other or multiply with each other, they are called terms. So terms, the definition for that, it consists of both variable and coefficients. Alright, so if I have -2 times x, I call it a term. Okay, -5/9 times x, I call this a term. So 5b is also a term. Negative AC is also a term. So there is an exception right here. So for example, if I have negative x, alright, so this is also called a term. Okay, so this is also called a term. So let me write it here and explain to everyone. So negative x is also called a term. And the coefficient in this case will be -1. Okay, it has a so this one is similar to -1x because the 1 is invisible. Okay, or we can have y. This is the same as 1y. Alright, okay, so keep that in mind. The number 1 as coefficient is invisible in the language of algebra. So if I have like terms means that I should have the same variables in each of my terms. So -2x and 3x are like terms because they have the same variable x. Okay, so they have the same variable x here. So therefore they call like terms. Okay, so variables, coefficients will make up a term. And when we have a term, we either have like terms or unlike terms. So unlike terms is when you have different variables. Okay, so here I have variable x and variable y, even though I have the same coefficient. Same coefficient doesn't mean that I have the same or the like term. Terms apply to the variables. Okay, so in this case, I have different terms. If I have -5x, -5y, 2b and 3c, they are different because they have different variables. Alright, so why do we learn all of this language? Because it's actually used to define a lot of rules for algebra. So if we go down to this next part of the lesson, okay, so now you see like term and unlike terms apply directly to addition and subtraction with the terms in algebra. So important rules, addition and subtraction can only perform with like terms. Okay, so for example, I am having this whole expression and I have to simplify it or perform the following operations as indicated. So that means I have to take 2x, subtract 5, subtract 3x plus 7y minus 9 plus y minus x. But I have to follow the rule here in order to add and subtract all of this term. Okay, so that means you are going to pick the one with the like terms in order to perform the operation that associate with it. So I am going to write it here that I'm going to pick 2x with the negative 3x because they have the same variable x, and I will combine that with this term here, right? So in addition and subtraction of the term, you leave the variable the way it is, and all you do is just taking the coefficient and perform the operation with the coefficient. So here I will take 2 subtract 3 subtract 1. So this is the invisible one right here. So I'm going to write up here for everyone to see. So I will have 2 subtract 3 subtract 1. Alright, so that will give me negative 2. So I write negative 2 in front of this x. And the next step is I have negative 5 and negative 9. Okay, so these are like term. Okay, or can call it, I can subtract the two numbers. Okay, so in language of algebra, this also called a term, because if we learn as exponent in previous unit, you can make up a term here. You can make a variable x to the exponent 0, x to the exponent 0, because anything raised to the exponent 0 is 1, right? So in language of algebra, this two number can consider as like term, or we just simply say that I can take this number and perform the operation with this number. So in this case, I will have negative 14. So that's what I have. Okay. The next step is I will choose the y. Okay, so that means I will have a plus 1. I mean 7 plus 1. I'm sorry, I'm ahead of myself. Okay, so when my mind think of a, I said a, but it's just really 7 plus 1 is equal to 8. Alright, okay, so keep in mind that if I just have number in algebra, I can also use the terminology as a term, okay, because like term here, because you can assign any variable for this two particular term and raise that to the exponent of 0. Okay, so in previous lesson we have this, right? Anything raised to the exponent 0 is equal to 1. Okay, so the next important rules is called the commutative properties and distributive rule. So distributive rule, and this is actually called the properties. The first one is commutative property of addition. So if you adding two numbers or two terms, you can switch the order of the terms. The order in which two numbers are added does not affect the sum. So if you have like 2 plus 3, it's the same as 3 plus 2. Alright, okay. Commutative property of multiplication. If you multiply the two numbers, a times b, the same as b times a. You can switch the position between these two, and you can switch the position between these two in terms of addition and multiplication. The order in which two numbers are multiplied does not affect the products. So for example, if I write x plus y, it's the same thing as I write y plus x. Okay, so if I say x times y, okay, so I put a bracket around this 2 to say that I multiply this 2, then it's the same thing I write y times x. Okay, or I can write it like this. I can say xy is equal to yx. Okay, so a few things for us to remember here. X times y equal to y times x. Okay, or I can write bracket x, bracket y, bracket y, bracket x. So brackets also representing multiplications. Okay, but in this case, we don't have to. The reason there's a bracket here is when you are writing like 2 or more terms inside each of this bracket, such as this part, A plus B. You see there's a bracket to represent that these are multiplication. Okay, these are the product. That means you take A, multiply each of this in the bracket. Okay, so if you have one term, or just one term in each of this bracket, you don't have to present it as a multiplication. All right? Okay, so I just erase this, and just to remind everyone that I can write x, y equal yx. All right, so it's the same as I take x times y, the same as I take y times x. So if you take 2 times 3 is equal to 6. 3 times 2 is also equal to 6. Okay, so I involve the brackets. That means I multiply this. If I have the 2 term inside this bracket, I have 1 term at the front, and I know that I apply distributive rule means that I have to multiply with each term inside this bracket. So I take A times B, there it is, and I add that with A times C. So this is the same as I'm writing AB plus AC. Okay, so I don't have to write a multiplication in between these 2 terms. If I don't have anything here, it's representing is multiplying with each other. All right. Now, so let's move on to the example. Expand and simplify. Okay, so or I can say distributive. Distribute the term. Distribute. Distribute is the verb. Okay, so I can distribute this by take the number at the front of this bracket or the term in front of the brackets. I must multiply with each term inside the bracket. That means I distribute. Or they can just say expand and simplify. Expand means that you have to get rid of all the brackets. Okay, simplify means that you have to collect the like term and then provide the final answer when you cannot simplify any further. Okay, so in this one, I will take this, multiply that, take this, multiply that. When it's a negative in front of this, it means that I have a negative 1. So don't forget it's a divisible number 1. So negative 5 times negative 2 would be positive 10. Negative 5 times negative x will give me positive 5x. You see? And then negative 1 times 6, I have negative 6. Negative 1 times positive 1, I have negative 1, and I leave the x here. So you see, no more brackets. That means that you expand. Okay? So now you simplify. It means that you have to collect the like term. If there's like term, you have to perform the operations for the coefficients. So here I have 5 subtract 1. Okay, therefore I have positive 4x. 10 subtract 6, I have positive 4. Alright, okay, so that's why I have this, and that's why I have that. Okay, so let's move on to solving for simple linear equation. So linear equation, that means you have one unknown. The exponent for x is equal to 1. If the exponent for x is 1, it means that you have one solution for x. Okay, so there are steps to solve a linear equation in this case. Okay, so simplify both sides of the equation. Don't forget, an equation is a mathematical statement which indicates 2 quantities are equal to each other. So I will have the left-hand side equal to the right-hand side. So this is called an equation. It's not the same as an expression. So let me go back and show everyone here that if I write it like this, okay, I write this statement like this. I just want to choose another number. I mean another color to show everyone. So this is this, right? This is called an expression. Okay, I put an equal sign here and nothing on this side means that we are going to perform the next step. Equal to what? I should put a question mark here. If I have something on this side of the equation, that means the equal sign, I turn this into an equation. I have something here on this side of this equal sign, I turn this into an equation. And on this side, I just ask you to perform the expression. Okay, perform the expression. So the difference between the expression and the equation is that it's giving you an equal sign and with something on the right hand side. So I have to simplify both sides of the equation, isolate the unknown by performing the same operation on both sides of the equation. Okay, check the answer by substituting the solution into the original equation if required. Excuse me. So in this remaining topic, I will ask everyone to work from example 3 to example 5, solve for x, where applicable, round the final answer to one decimal place, check the solution to prove that both sides are equal. Okay. Alright, so if we check both sides are equal, then if our answer is in fraction, then we need to keep it in fraction in order to check. Alright, so let's start with this. So the step here told us that we should simplify both sides of the equation. I don't need to simplify here because I cannot take negative 7x subtract 8. They are not like term. 35, which is 35. So I go right into step 2, isolate the unknown by performing the same operation on both sides of the equation. Okay, so how do I perform both sides of the equation? To what purpose? Because I want to isolate the unknown. The unknown here is x. So I need to have just negative 7x by itself on one side of the equation. So the one that I have to get rid of is negative a, or subtract a. So that means I am going to perform the operation so that I can get rid of the minus 8. So negative 7x minus 8. Okay. Then what I need to do is I'm going to add 8. So I'm going to give myself some room here. So I'm going to plus 8 here, because subtract 8 plus 8 will give me a 0. Okay. Because I am working with equation, I do the same thing on the other side. I also have to add the 8. So you see that and that cancel out. And you just have negative 7x left. So now you're almost there when you want to isolate x. So this equal to 43. Okay. So the right hand side equal to 43. Now I'm going to get rid of the x. I mean get rid of negative 7 in front of x. I need to solve for x. So I just have to have one x left. So you have negative 7 times x. In order to get rid of this negative 7, you must divide both sides by negative 7. So I do the same thing on this side. Okay, so I just apply the simple step. There are a few other ways of solving for this simple equation, a linear equation, by performing the reverse operation. But I'm not going to go into that. It's way like advanced algebra. So I just perform the step indicated to me here, that I perform the same operations on both sides of the equation. Okay, so now this gives me x equal to negative 7 divided into 43. So I should have negative 6.1428. And the question asked me to round to one decimal place, so I round to one decimal place. Okay, so we want to review the rounding here. So round to one decimal place, that means you take a look at the second decimal place. It is 4, it's less than 5, so you leave the 1 alone and you discard the rest of this. So negative 6.1. So the next step, as I'm asking everyone to do, is to perform the step to prove that the two sides of this equation are equal to each other. So to do that, I will write left hand side. Okay, and here I know that the right hand side is actually equal to 35. So whatever I do on this side, I should end up with 35, right? So 7x subtract 8. See, I rewrite the entire statement for left hand side. Now I'm going to substitute in here x as negative 43 over 7 subtract 8. Okay. Using your calculator, or you can just perform the step to subtract the fraction. And best math means I have to take -7 multiply with this fraction first. Multiply a number with a fraction. I multiply this with the numerator. So -7 multiply -43 will give me positive 301. Okay, but I would like everyone to note this. Okay, so if I write this as this, okay, I just want to show everyone here. I have the solution written like this. So I'm going to write the exact same, okay? 43 over -7. Okay, so what you can do is you can take that and cancel with that right away as simplification. Okay, so if you cannot simplify, then you need to take that, multiply by that, divided by that, which I was trying to do from the very beginning. However, if we can apply the shortcut by just take this, cancel with that, because you have the same number as the top and the bottom. So this will give me 43 minus 8. So this is 43. And minus 8 will give me 35. Okay, so this and this is actually equal to each other. Right? So then I achieve the purpose that I check both sides of the equation. And I have left-hand side equal to the right-hand side. Okay. So the solution should be equal to -43 over 7. And I don't use the round number here to check, because it may not come to the exact left-hand side equal to the right-hand side, because I already round my number. So when you check the solution, leave your answer here, the final answer, as fraction when you check. Okay, so we apply to the next example. Okay, apply this to the next example. I should have -2x subtract 8. So I write it to make sure that I perform the operation on both sides. So you see that this is subtract 8. I will plus 8, and I do plus 8 on this side. All right? Okay. So, and I want to have all the x over to the left-hand side of the equation. So somehow I have to get rid of that -7x. So I am going to add that with 7x. So then I do the same thing here. I add this with 7x. So now you see you have that cancel out, that and that cancel out. So in the end, I have 5x on this side. In the end here, I should have 28. Okay, so -2 plus 7 will give me +5. Now I divide both sides by 5. So I will that cancel that. Therefore, I have x equal to 28 over 5 and should give me 5.6 as the answer. But I'm going to, now I will do left-hand side and the right-hand side. So I'm going to check solution on both sides, okay? And I'm going to use this value to check. So the right-hand side is -2x minus 8. Okay, so I will go -2 times 28 over 5, subtract 8. So in this case, now, as I did in previous example, I immediately take this number, multiply the numerators, because I cannot cancel -2 with 5, right? So in this case, I should have a -56 divided by 5, subtract 8. Okay, and in this case, I need to perform the step to subtract these two fractions. So I must have the same denominators here. So I will have it as 5 times 5 as the denominator. So this have to multiply by 5 as well. So I have -56 subtract 40 over 5. So this should be -96 over 5. Okay, as the answer for the left-hand side. So now let's try the right hand side to see if I end up with negative 96 over 5. Okay, so in the end you target this number. You substitute x in here, you perform the bad math involving the fraction, and then you come up with this answer like this. Now you do the same thing on the right hand side to see if you end up with the same number as negative 96 over 5. So on the right hand side, I have negative 7x plus 20. Okay, so the equation here, that is your right hand side, and this is your left hand side. All right, okay, so I will have negative 7 times 28 over 5 plus 20. Okay, I do the same thing, perform the operation using fraction. So I take negative 7 times 28. Okay, so I have negative 7 times 28. I will have negative 196 over 5. At the same time, I have to change 20 to have the same denominators. So it will be 5, then 20 times 5. Okay? So 20 times 5. So I have negative 96 plus 100, the whole thing divided by 5. So in this case, I should have negative 96 over 5. Okay, so I have, they are equal to each other, right hand side equal to the left hand side in this case. All right, very good. So let's move on to the next example. Okay, so in this example, I need to multiply this inside the bracket. So I have positive 2x, positive 12 will be equal to negative 11 plus x. Okay, so I will perform the step to get rid of the numbers on one side and isolate the x to the left hand side of the equation. Okay, so the first thing I do is I subtract the 12. So I do subtract 12 here. So the next thing I do is I put negative x. So here I should have negative x. Okay, so check that and that cancel, and the x cancel on this side of the equation as well. So in this case, I should have x equal to negative 23. Okay, so 2x minus 1x will give me x, and negative 11 subtract 12 will give me 23. So now the left hand side is equal to negative 2, and I multiply that with negative x minus 6. So it means that I will have negative 23 minus 6. Okay, so a lot of bad math here that we need to be mindful. So I should have positive 23 plus subtract 6. Okay, so here this is negative times negative will give me a positive. So this one is subtract 6. Okay, so inside the bracket I should have 23 subtract 6. So that should give me a positive 17. And multiply that with negative 2. And then it should give me negative 34. So let's see if the right hand side is equal to that as well. Okay, so the right hand side is equal to negative 11 plus x. So I should have negative 11 plus minus 23. So in this case, I should have negative 11, negative 23. That should give me negative 34. So left hand side equal to right hand side. All right, so and I know that if the left hand side equal to the right hand side, when I prove it, it means that my solution is correct. Okay, so in solving for x, you have a choice that you can always check your solution to make sure that you get a correct solution. Alright, so if you have fraction, you make sure that you use fraction when you check. And I do have quite a lot of exercise for everyone to work on. Alright, okay. So I will end the video here, and it's almost 30 minutes for this video. Alright, thank you everyone.